Welcome. So here we're going to talk a little bit about dividing fractions. Just why does it work? So when we divide fractions, we do a process called multiply by the reciprocal, also known as copy dot flip. And we want to talk a little bit about why it works, and just here's one way of thinking about that process. So I'm going to begin with some whole numbers and what we do when we're doing division, and try to get to a point where we're really, kind of thinking about this. So let's consider 12 divided by 3. Whole numbers, right? When I ask this question, this is the same as saying 3 times what number equals 12, right? I'm looking at what is that number, that unknown number. 12 divided by 3 is the same as saying 3 times some number equals 12. And if I'm solving this from a, simple algebra standpoint, I divide both sides by 3, right? These are equivalent statements. X equals 12 over 3. And that means that x equals 4. So just to start, that's what I'm doing when I do division. I'm saying there's some unknown number, x, and when I multiply it by 3, I get 12. We're doing kind of the same thing when we divide fractions. Let's consider 1/2 divided by, let's start with a whole number. Let's work up to that. Let's do 2 divided by 1/3. This is the same as saying 1/3 times what number equals 2, right? So what I do when I solve this problem is I end up multiplying both sides by 3, right? The 1/3 is the same as dividing by 3. So if I multiply both sides by 3, I end up with x equals 6. And if I'm looking back at my original fraction, 2 divided by 1/3, if I multiply by the reciprocal, that's 2 times 3 over 1, which is also 6. So I'm basically solving a simple algebraic equation every time I do this. Let's do one more example where we have 2 fractions. If I now have 2/5 divided by, let's keep the 1/3, right? This is the same as saying 1/3 times what number, some number, x, equals 2/5. Sorry, I don't want to do 1/3. I apologize. Let's go ahead and change that because we want to use a more complex number in order to show the work. I apologize. Let's start again. Let's do instead 3 over 7. Okay. So here I have, because I want to do something that's a little more complex than we did in the previous. So here, 2/5 divided by 3 over 7. This is the same as saying 3 over 7 times some number x equals 2/5. And I'm trying to solve for x. Every time I do this, I have a 7 in my denominator, so I'm going to multiply both sides by 7. So I have 3 times x equals 2 over 5 times 7. Then I'm going to divide both sides by 3. So I have x equals 2 over 5 times 7 over 3. This is my answer to this problem, and it is the same as multiplying by the reciprocal, otherwise known as copy dot flip. So I've changed to a multiplication, and I have my 7 as the numerator and the 3 as the denominator. So the reason that this process works when you're dividing fractions is because it is the nature of the way that we solve algebra problems. When I have that denominator, I multiply over, so it becomes essentially the numerator. And then the 3, which was in the numerator, when I divide, it goes into the bottom, it becomes the denominator. So that is why this copy dot flip process works. And that's a little bit, or at least that is one way of visualizing that process. Thank you so much.